Okay, so I want you to think about something for a second. What if I told you that for a really powerful type of AI, you could just throw out the most expensive, most time consuming part of its training and replace it with, well, basically a roll of the dice? Today, we're going to dig into some fascinating new research that suggests randomness might just be the secret ingredient to a way smarter and way more efficient future for AI. So let's just jump right into the big question here, because it's a wild one. What if a huge critical part of what we call AI training was just completely unnecessary? I know, it sounds nuts, but stick with me here, because some new research is pointing to the idea that for a very specific and very powerful kind of AI, we might be able to swap out all that intense, expensive effort for something as simple as pure chance. All right, so how is this even possible, right? To really wrap our heads around this radical idea, first we got to talk about a special kind of AI, one that sees the world not just as a big list of things, but as this deeply interconnected web of relationships. They're called graph neural networks, or GNNs for short. Think about a social network. It's not just about the people, right? It's about who's friends with whom, the connections between them. GNNs are absolute experts at understanding these complex relationships. It's what makes them perfect for everything from mapping out our friendships and powering recommendation engines to analyzing the super intricate structures of proteins. Now, traditionally, the power of a GNN comes from something called learned weights. Just picture millions of tiny little knobs inside the AI's brain. During a super long, super computationally expensive training process, the AI painstakingly adjusts every single one of these knobs over and over and over again. It's trying to find the absolute perfect setting to get better at whatever its job is. And let me tell you, it takes a ton of time and computing power to get it right. It's kind of like a master chef who spends decades perfecting a secret recipe, you know? Every single little adjustment is deliberate, it's based on feedback, and it's all aiming for that one perfect, flawless result. This slow, expensive, methodical process, well, everyone just assumed it was absolutely essential for these advanced AI models to learn anything at all. But what if we could just toss that whole recipe book out the window? This is where things get really interesting, thanks to a group of researchers who decided to try something that honestly sounds completely backwards. So, right there in their research paper, they make this startling claim. They say random weights can be surprisingly effective, achieving performance comparable to trained counterparts. I mean, let that sink in. They're basically asking, what if we replace that methodical master chef with nothing more than a simple roll of the dice? And this little comparison here just lays it all out. On one side, you've got the old way, slow, expensive, super intensive. And on the other, this radical new idea, lightweight, efficient, and cheap. And how do you do it? By just setting all those internal knobs to random values and just leaving them there. The big question, of course, is, could that actually work? Well, the answer, it turns out, was a massive yes. And the results weren't just kind of interesting. They were genuinely shocking. I mean, they challenged a core belief that a lot of people in the AI field have held for a long time. So here's the absolute kicker. The GNNs that were using completely random weights performed just as well on a whole bunch of difficult tasks as the models that had gone through that entire expensive, painstaking training process. That perfect recipe that took decades to craft, yeah, it was basically matched by random chance. But the benefits didn't even stop at performance. Oh no, the efficiency gains were just absolutely massive. For starters, these random leap models trained up to 6 times faster. 6 times! I mean, that means something that used to take 6 hours of a supercomputer chugging away could now, maybe, take just 1 hour. But it wasn't just faster. On top of that incredible speed up, they also used up to 3 times less memory. And that is a total game changer. It means these really powerful AI models could potentially run on much smaller, much less expensive hardware. We're talking maybe even on the devices that you and I use every single day. So this table really just puts it all into perspective. Look at this. The random weight GNN gives you comparable high-level performance, but it's up to 6 times faster and uses a third of the memory. You're getting basically the same quality result for a tiny, tiny fraction of the cost and effort. It's an almost unbelievable trade-off. So now we get the billion-dollar question. How is this even possible? How can random chance compete with careful, deliberate learning? Well, it turns out The randomness isn't just a shortcut. It's actually fixing a hidden fundamental problem that's been lurking in traditional GNNs. And that problem has a pretty technical name. It's called feature rank collapse. So as traditional GNNs get more and more complex, they can actually start to oversimplify the information they're processing. I want you to imagine all the different, vibrant colors in a beautiful painting being slowly blended together until you're just left with a single muddy brown color. That's kind of what's happening. The AI loses all the distinct, important details, and its predictive power just tanks. And here's the magic. The random weights, they act as a disruptor. They stop the AI from blending all those beautiful, vibrant colors into that useless, muddy brown. By actually preserving the diversity and the richness of the information, the randomness makes the network more robust and, in the end, way more effective. So, what does all this mean for the big picture? I mean, this isn't just some clever trick for a research paper. This really points toward a future where powerful AI is way more accessible, far more efficient, and a whole lot more versatile. So why is this such a big deal? Well, for one, it means researchers and smaller companies could get access to incredibly powerful AI without needing a giant supercomputer. It dramatically slashes the cost and the time it takes to develop new AI tools. And because these models need so much less memory, they could even, maybe, run on your phone. This is a whole new way of thinking about how we design artificial intelligence from the ground up. And that just leaves us with one final, fascinating question to chew on. If our really structured, complex, expensive learning process can be matched by simple randomness, then what are we really talking about when we say an AI learns? This research gives us more than just a powerful new tool. It really challenges us to rethink the very nature of intelligence itself.